Here we have an example that's asking us to differentiate, which just means find the derivative of this equation. And then they always put this with respect to x just to let us know that x is the variable we care about. So what we're looking at for an equation is f of x equals arcsecant, that's how you say that, of, and then 3x squared minus 8x plus 5. This also, some people will use secant inverse. They're the exact same thing. Arcsecant, secant inverse. It really always depends upon where you go to school and what your teacher uses, which one you'll see. But they're interchangeable. So no matter which one you get, this is what this would be your method that you want to use. Arcsecant, any of our inverse trig functions, they fall into a category of derivatives that I just call special case derivatives. So they're derivatives you just have to have memorized. There's no real other way you would get to them without having these things memorized. So for this situation, if f of x is equal to the arcsecant of x, then the derivative of this is going to be equal to 1 divided by the absolute value of x times the square root of x squared minus 1. The thing about all of these special cases to keep in mind is as soon as I replace that x, as soon as somebody replaces that x with anything more than just x, as soon as that becomes anything more than just a basic x inside there, you're going to be looking at a chain rule problem. So the majority of special case problems that you run into are going to end up being chain rule problems because very often you're not just given a basic little x inside there. As we can see on this specific problem, we definitely have something more than just an x inside our arcsecant. So something more than just an x there tells us that we need to apply the chain rule. So my chain rule saying that I like to use goes d in times d out. So the derivative of whatever is on the inside of our function times the derivative of whatever is on the outside. So as we look here, what we can see is whatever they replace that basic x with in your function, that is your inside piece. That's what got plugged into this arcsecant equation. So we break them into bite-sized problems, and I say, okay, for the in piece, I have 3x squared minus 8x plus 5. And I need to go find the d in, the derivative of that in, to do my chain rule. Looking at that in piece by itself, well, that's just a bunch of stuff being added and subtracted. And so all we're really looking at here is our power rule. So really, again, everything flows through the power rule usually at some point in time. So the power rule, right, just says bring the power down and then subtract 1 from the power. So following our power rule here, bringing our power down, we get 2 times 3 gets us 6x, subtract 1 from the power gets us x to the first. Then we've got an unwritten 1 on that x. We bring that 1 down. 1 times negative 8 gets us negative 8. And then subtracting 1 from the power gets us x to the 0. And anything to the 0 power is just 1, so we can just drop that off of there. And then the derivative of 5, the derivative of a constant, is always 0. Now what we need is we need to go find the d out, the outside piece. Well, that is where this special case comes into play. The outside piece here, this really is your arcsecant, your secant inverse. That's what you're going to need to take the derivative of. So this is going to follow our special case rule to find that d out. So our x inside really is all of this stuff that we already took the derivative of. And so anywhere we see that x in our derivative rule, we replace that x with this full chunk right here. So our derivative on this is going to end up being, following our special case, this will be 1 over the absolute value, and instead of x, we have all that stuff that replaced x, 3x squared minus 8x plus 5, and then we're going to multiply that by the square root of, and again, that's all that same stuff inside there. Probably going to need a little more room because this thing's a little long. So squared. So that x is all the stuff that replaced x. So 3x squared minus 8x plus 5, and then the rule has that little minus 1 at the end. So that is the derivative of the outside piece. And now that we have the d in and the d out, we've got all the ingredients we need to follow our chain rule recipe and get our derivative. So following our rule, our chain rule, our derivative will be derivative of the inside, 6x minus 8, times the derivative of the outside, which is all that stuff. So 1 over the absolute value of 3x squared minus 8x plus 5 times the square root of 3x squared minus 8x plus 5 squared, and then minus 1. And that's it. Walk away. You're done. You don't need to simplify that thing anymore. Someone asked you for what the derivative was. You followed your derivative rules. You give them out as this is the final answer. And just, again, stand up, walk away. You're done. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.